So in this video, we're going to be talking about inscribed angles and intercepted arcs. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords or secants, depending on if you have a line or a segment. Okay, so we've got an inscribed angle here because the vertex location is on the circle. And the segments go out and they capture what's called an intercepted arc. So an intercepted arc is the arc that is captured by extending the chords of an inscribed angle. Okay, so there's going to be a relationship between the inscribed angle and the intercepted arc. And that relationship is that the measure of the inscribed angle is half the measure of its intercepted arc. So in this specific diagram to the right, the measure of the angle, ADB, will equal the measure of the arc, AB, divided by 2, or half that arc. Okay, because I extend these chords out and it captures this minor arc here. All right, another way that could look is if you have a tangent in a chord that intersect. All right, so here you got a tangent in a chord, but once again, the vertex location is on the circle. So like if I look at angle 1, if I extend these lines out, it captures this arc here, arc AB. So the relationship is still half the intercepted arc. So the measure of angle 1 is going to be half the measure of arc AB. Same thing with angle 2 here. Angle 2, if I extend these segments out, it's going to capture this major arc here. So the measure of angle 2 is going to equal the measure of arc BCA divided by 2. It's going to be half that major arc. So basically, to summarize, if your vertex is on the circle, angle equals arc divided by 2. That's kind of your general formula for if the vertex is on the circle. Okay, so we got a diagram here. Find the indicated measures. So we want to find the measure of angle S. So the measure of angle S, which is an inscribed angle. So if I extend those chords out, notice how it captures this 60 degrees. So the measure of angle S is going to be half of 60, or 30 degrees. Okay, because the measure of the angle is half the arc. Okay, so if we're going from an arc back to an angle here, we're going to divide by 2. What if we wanted to find the measure of arc RQ? Find the measure of arc RQ. Well, we don't have an inscribed angle to go with that. Okay? But we do see that this is a semicircle. RQS is a semicircle with this diameter. All right, so if I take this 37 and I multiply it by 2, I'm going to get this arc here. So 37 times 2, arc QS is going to be 74 degrees. All right, and the whole semicircle is 180. So 180 minus 74, that's going to give me arc RQ. So the measure of arc RQ is 106 degrees. All right, so we can take an inscribed angle and figure out what its intercepted arc is, or we can use an intercepted arc and figure out what the inscribed angle is. But we can't forget stuff about semicircles, how many degrees are in a circle, all that stuff, because those are sometimes helpful. Because like RQ did not have an inscribed angle, all right? It was not an intercepted arc. So we had to use other facts about our circle in order to figure out what that measure was. All right? So what about line M, or example 3? We got line M, which is tangent to the circle. We want to find the measure of angle 2. Well, there's a couple ways we could do this. All right, the tangent is a line. This angle is 110. So if I wanted to find that angle, we could just do 180 minus 110 and get 70 degrees. So the measure of angle 2, we could use just the fact that it's a linear pair and do 70 degrees. All right, what if we wanted to use this new idea of intercepted arcs and inscribed angles? Well, angle 110 degrees is an inscribed angle because the vertex is on the circle. And if I extend its chords out, it captures this arc right here. So the measure of this arc, measure of arc DFE is going to be 220 degrees because I can multiply that inscribed angle by 2. All right, and if the whole circle is 360, that makes this arc over here 360 minus 220, or 140. And then if I wanted to work backwards from an intercepted arc to the inscribed angle, I would divide by 2. And 140 divided by 2 gives us this 70 degrees. So there's a couple ways that we could solve this one. Either using just the fact of a linear pair. Don't forget that if angles make up a straight line, they have to add up to 180. Or we could use this new idea about inscribed angles and intercepted arcs. Okay? And then, lastly, example 4, we got measure of arc HGJ. We're trying to find the measure of arc HGJ and measure, I'm trying to find the measure of angle HGJ. Talking about this angle right here. And I'm trying to find the measure of arc HJ. All I've got is this angle of 39. So if I extend this inscribed angle out, you will see that it captures the arc I'm trying to find. All right, so 39 times 2 is going to give me that arc. So 39 times 2, measure of arc HJ is 78 degrees. Measure of arc HJ is 78 degrees. All right, now we're trying to also find the measure of angle HGJ. So this is another inscribed angle because the vertex is on the circle. So if I extend these chords out, notice that it also captures 78. So to find this, I got to take 78 divided by 2. So the measure of angle HGJ is 39 degrees. Well, notice both of these angles were 39, which means that those angles were congruent. What did they do? Those angles both captured the same arc. So if two inscribed angles of a circle intercept the same arc, those angles are going to be congruent. All right, something that might just help speed up the process so that you didn't have to do all that work. But the big relationship here is that if your vertex is on the circle, angle equals arc divided by 2. So then you can find missing arcs or angles using that relationship. Angle equals arc divided by 2 if the vertex is on the circle. All right, so just make sure you understand that property. In the next video, we'll talk about what if the vertex is inside the circle. So make sure to tune into that next video.